My name is Daryl Keaton. I said Daryl Keaton, but I am one of the organizers for Startup Week. One of my roles was as community evangelist was to go out in the community and find unique ways to build businesses back into the startup community during this whole week. So one of those efforts was to really identify a gap where a lot of businesses are going through product assumptions or experiments and different iterations, but not really sure how. So we wanted to provide some examples through actually people that are going through the early stage, they're going through now revenue, and the ones that have already started to scale. So in our second presentation today, we have Philip from Touchpoint Solutions. He's done more than one product development. He's done consulting, and now he's a chief engineer at Touchpoint Solutions as they go into their product expansions and development over time. So I'll actually let Brandon kind of come in and introduce really about the product design lifecycle in the phase 2 and how Philip will really give you guys an engaging experience of what he's doing to enhance their business. Brandon?
Awesome. Thank you, Philip. Thank you, Daryl. Yeah, so phase 1 was problem identification and exploration, as we saw with their story. Phase 2 becomes then the execution of the ideation of what your solution is going to be, and the prototyping and the manufacturing, and this whole stage. So for that we have Philip. He is a chief engineer at Salted Earth and the founder and chief engineer at Touchpoint, founder and chief engineer at Salted Earth. He has electromechanical experience, 10 years, right?
Mm-hmm.
Right, okay. And 15 years of experience in high volume manufacturing. Worked in numerous market sectors including aerospace, robotics, manufacturing, industrial automation, medical wearables, which I think is...
That's Touchpoint.
That's Touchpoint, and consumer electronics. And has worked with companies spanning all stages of product development. So today, we've got an expert here. I'm going to let you take it from here.
Thanks. So I'm originally from New York. So if I talk fast, just somebody give me one of these and I'll slow down. All right. So I like to start off with a quote, and this is one that resonates with me quite a bit. How many of you are working on a hardware project of some form? Yeah, a bunch of you. Okay. So how many of you tried to go out for investment for your idea? Any idea? Yeah, a couple. So vision without action is a daydream, and action without vision is a nightmare. Or as investors like to put it, ideas are worthless, what's your revenue? Because what they're really summarizing here is, if you have an idea and you don't act on it, it's worthless. It's in your head. You'll be the guy who's shaking your fist at the TV saying, "I invented the Snuggie, but you didn't bring it to market, so it didn't do anything." And then what's your revenue? Did you execute on that idea and actually bring it to market? And were people willing to buy it? So what we're going to cover in this is the 3 phases of product development that I tend to break them down into. We'll go through Touchpoints, which is a company that I joined 6 months ago, basically to take their product, which had all forms of manufacturing problems, and they had rushed to market, and it was basically their first iteration of the product, and taking that and wiping the slate clean and kind of redoing it. And then some tools and equipment that I tend to use quite frequently, and I'm surprised people in this space don't know about. So first off, who am I? I'm that guy on the ground getting arrested by a SWAT team. We're all smiling though, having fun. So the first company that I actually founded, I am a multidiscipline engineer, and I'm also a serial entrepreneur. So the first company that I personally founded was Salted Earth. We make laser-based firearm training equipment. So we're going to kind of go through the development of that product, because that started literally from the idea phase from scratch. And now I'm the chief engineer also for the Touchpoint solution. We make little medical wearables, if anybody was here yesterday for our CEO's presentation. Also work for a bunch of other companies, some in the Valley, some on the East Coast. So the 3 ways I break down product development are prototype, pre-production, production. There's a million steps in between. You'll often hear people talk about the startup grind, but when you're dealing with hardware development, you want to try to avoid the grind at all costs, because it basically just will wear you down. You'll have creative blocks. It's really a mess. So I break it down to 3 major steps. So for the prototype phase, we're really focusing on the features that differentiate your product, something that is unique to you, and it's something that you're probably uncertain about, that you don't know if it's going to work. That's the spark you had. You might have this vision of it working, but you need to make sure you actually test it. And what I see a lot of people, a lot of companies do during the stage is they run out and they try to find somebody to design electronics for them or the mechanics, and they don't realize that a lot of what you need is already in kind of a breadboard form, puzzle piece form. And you can go to any one of these sites. I use SparkFun and Adafruit all the time, even for major projects and major corporations, to get the building blocks, put it together. It's not going to be pretty. It's not going to be in a nice little form factor that you can wear on your wrist, but it's to test your theory before you actually start committing major amounts of capital. I should also know, because he's somebody taking pictures, I will share this presentation afterwards. So if you see something, if I say something that's not on the screen, take notes, but otherwise, I'll share this with everyone. So the prototype phase is always messy. The Kegel Bell, you guys started out really nice and clean. Most projects don't start out like this. So this was my first prototype that I built of the salted earth laser trainer. It is literally held together with duct tape and rubber bands. And actually the lens on the front is tissue paper that I stole from my girlfriend. So it's not pretty, but really all this was trying to do is test the sensor, because if the sensor didn't work, nothing else was going to work. So I built this in the course of a day from scrap parts from a lot of those websites that you saw, and tested out the theory. I actually even went one step further and put this in front of a law enforcement agency to see if they would use this technology or not. You can go to a patent attorney at this stage. They've seen a lot worse. What we ended up going to the patent attorneys with was kind of the next step. So it's still a prototype. It's off-the-shelf electronics with one custom board. So we took that sensor. We go, okay, the sensor works. Now we need to integrate that into the product. So we did. And when we went to our attorneys, they go, wow, this is the nicest prototype we've seen in forever. And I patted myself on the back for that, but months later I realized I wasted so much time because it doesn't have to be pretty for the attorneys. They're not going to be your customer, right? And they're the ones that you sign a really lengthy agreement with, saying that they're not going to tell anybody about what you're talking with them with. So don't wait. You guys did it the right way. Even if you just have a drawing, get out there and start patenting right away. Also, be very careful demonstrating your product. I see a lot of hardware companies in the Valley which will show up with a product that has all of their IP kind of exposed to the world. And someone like myself, I can take one look at your product and I can basically reverse engineer it. And there's other people like me. So just be very careful when you're doing that. I would stress to everyone in this room that if you're trying to work on any type of product, that you need to have a big network. There's one group in Arizona, Yes Phoenix, which I have met most of the other entrepreneurs. I think that's how we probably met too. Join that group. You have a whole slew of contract manufacturers in Arizona. QuickTech's one of my favorite, that they will work with startups. So you really need to network as quickly as you can, because the bigger network you have, if you have a problem, you're probably not the first to have that issue. And you can go to somebody like QuickTech and go, hey, I'm having a battery charging problem. And they've probably had a customer before that had a similar issue and can at least help you out. So next is the pre-production. This is usually the stage everyone runs to crowdfunding. They don't really have their product at a point where it can be manufactured. They just have that pretty model and a pipe dream. So switch. I don't know if anyone knows what Kapton tape is. Nope. John, a hardware joke that was lost on you guys. There are a whole slew of DFM stands for Design for Manufacturing. So there's a whole slew of online tools. Shapeways was the one that I blurted out before. Shapeways, when you're dealing with 3D printing, has an entire library of all the materials they print, all of the design specifications. How thin can you make something? What's the overall, the biggest size they can handle? Local? Shapeways is not. They are on the East Coast.
Stax is the
Stax? Okay. Proto Labs is another one. They're an injection molding company. But what they do is they have an entire library of white papers on injection molding design and all the requirements there. If you upload your parts to their website, they'll also do a little study on it to tell you and give you some advice on what you should change before you go to manufacturing. And then I generally advise that people start to invest in higher quality 3D printed parts, because you want to test your injection molded product. So this was our pre-production device. It's a major step in the aesthetics category. Still a little bit of a bird's nest of wires. But like I said, you cover your naughty bits. So you're going to really want to focus on features that are going to get you your first customer. I see a lot of companies that focus on what's going to make their product look cool to investors and try to get the money. But the investors are going to go back to that first quote and ask you what your revenue is. They don't really care that this is pretty and it's exciting. They're going to want to know how many you've actually sold. I would also highly advise to not create what I call a glass cannon. I've seen tons of prototypes that are absolutely gorgeous and visually appealing, but if you look at them too hard, they'll just explode. Because you really need to get this in the hands of your users and get them testing it. Obviously, if it's something that you're inserting into the body, there's some more requirements in terms of materials. So this might not work for you, but for most electronics projects, if I could put it in a nice housing and hand it to somebody to use, I'm gonna get realistic testing. We built 24 of these, and 3 years later, they're still out in the field. One of my favorite quotes that I like to use in terms of production: why not go out on a limb? That's where the fruit is. So you've gotten your device to the pre-production stage. You have hopefully listened to your customers, and now this is kind of the biggest leap of faith that you're going to take to actually get your product into the market, because it is very expensive. For our particular product, we dropped close to $140,000 in just injection molding tooling alone, not including boards and parts and assembly and anything. So you really need to make sure that you go through this process. And when we go through the case study, I'll share the tools that I use when I'm actually designing the products. But you need to validate. A lot of companies will run to market as quickly as they can, or they'll rush to the crowdfunding stage, and then they'll get this huge sum of money, and they go, "Holy shit, we made $250,000," and then they don't realize, like, well, half of that's going to go to injection molding tooling, and they don't account for that. And sometimes you just have to do it yourself. We built the first 250 of these in my garage in 110-degree heat. Just sometimes you just got to do it. So that was Salted Earth. That project was started literally from like day one of me drawing a sketch out. Touch points. Unfortunately, as it was mentioned, that I do a lot of consulting work around the Valley, the West Coast. I still have some clients on the East Coast from when I used to live in New York. And generally, I am brought on board when they have runs of broken parts and they're running out of money and they need to make the thing work and actually get it to market, which is not the place that you want to be as a consultant. They usually give me the puppy eyes too. So when I started at Touchpoint, the first generation of their product was on the left. It's nice, it's sleek. They weren't all pink, but it's nice and sleek. It worked quite well, but it didn't have all the features. They needed better battery life, so they went and they got into a design firm. Very important to know, every engineer, just like any sculptor, is going to have a style. They're going to, their skill level is going to dictate what your end product looks like, because it's based off of their experience of designing products for however many years. So they designed this product that our customers have labeled a Tide Pod. It is not a very good looking device. It had a whole slew of manufacturing problems, which brings us to our first point. You'll hear this a lot. People will, especially if you're starting out a company and you're not the tech founder, you're going to go out and look for a freelancer or some type of engineer to work on your project, or maybe you're going to hire in-house and you're going to look for people, and they're going to tell you, "Oh, I designed for manufacturing." And to me, that's really common sense. It's not a value add. No one in here would design a product that's hard to make, right? Right? You would never do that. So something that people don't quite understand when they're going through this design process: if you make your product hard to make, contract manufacturers don't have to work with you. They have millions of clients around the world that they could choose from. If you make something that's too difficult for them to make, they'll just back away from it, and you'll be left doing it on your own. A lot of people won't even put their product together themselves. If you can't put it together on the kitchen table as a prototype, they're not going to be able to do it in manufacturing. So you need to be able to do it slowly. And then you might have to design your own tools, which we'll get to later. So the first step, pretty much whenever I am designing a product, is I start in mechanical CAD, which stands for computer-aided design. This is the most powerful tool that you have. I have, at the end of this, when I'll share it, I have a list of different CAD packages. Some are actually free now. One thing to note is, generally when you're dealing with any type of mechanical product, companies are very quick to do the industrial design. They want to make this look pretty, and it's got little dots on the back. But they don't design what's actually inside the device, which is really the most important part, especially for manufacturing. So this tool allows you to literally go down to the resistor on the board and model the resistor and put that in there and make sure that everything, your housing's going to clear. It allows you to do finite element analysis and know, did I make this thick enough? Is it strong enough? If I put too much weight on my kegel bell, is the cord going to snap? It allows us to make sure that the parts fit, which you would think would be really obvious, to make sure that all your parts fit. But most of the problems I've seen in manufacturing is because they didn't do that. And you can also do mock assembly runs. You can actually, in the CAD software, go piece by piece and put this together and make sure that the way you designed it makes sense. Are you going to be able to fit this board in the right way? If you have wiring harnesses and things that are complicated, you can do that in the software. I haven't always designed small things. I've also designed big things. That's me right there in the center before I was very jaded about life. And the one thing to note is that the propeller system in the back actually has 140 parts. inside that one assembly. So this is kind of a more extreme case, but every part needs to fit. Every part it has an interface. It's connecting to something. And in the software, I can cut this model any direction I want. I can see every part on the inside. A lot of these software packages now even have sections of the software which will check for interference for you. So if you get to the end of your product design and the parts don't fit together, it's your fault, because the software lets you do whatever you want. Ah, yes. How many software guys do you have in your room? A bunch. Damn. Oh, you guys thought this was about software. It's not. This is just a joke. So another really powerful tool that I find very underutilized, or you can kind of use this for good and for evil. I ask you and I beg of you to use this for good, because a lot of times what you'll see on Kickstarters and Indiegogos, this is what they're showing. They actually don't have a physical, tangible product, or they haven't actually created it. They're just using a rendering. But nothing on this screen is real. This is all based off of the CAD models that gets brought into a second software package. I use Keyshot. This whole section might seem like an Autodesk pitch. I swear I don't have any money in them. I've just used their software a lot. I have about 15 years of experience in Inventor. But now the thing is, everything you're designing, obviously you want to create and make a real product. So everything on the top is the rendering. Everything on the bottom is the real thing after it was manufactured. So, and in some cases like this, most people think that's the real one and that's the fake. It's the other way around. So you can use this software to do all types of customization. Actually, Mark, who's not paying attention, actually drew those stickers by hand. And we're doing a contest with our customers right now before this product's even launched, to get them engaged with the product. And we're having a whole sticker contest where we're letting any of our users basically create their own. And we can go into the software and model it to the point where most people wouldn't know this was fake. But we can also test configurations. If you have a product that comes in multiple colors and multiple styles, you can go ahead and you can render all of that in the software before you've ever even committed to manufacturing, and see if your customers even like it. Because you might think that gold is a great color and your customers might think that that's not. So you can test that in software, and I really encourage people, even if you don't have the experience, you can go on like Fiverr, Upwork, and all these sites, and probably find somebody who can do this for you. But if you get this done, I can guarantee you your customers won't tell the difference. I was actually disqualified from an engineering competition at one point because you weren't allowed to use a real product, and I actually had to type "this is a render" and put it on all of my images that I submitted because they kept disqualifying me. So I think most consumers at this point in time expect their devices to be customizable. Everybody wants something that's different color, different style. So it's just something I'd like to bring up, because we experienced in this product is most people will run to the plastics and go, okay, we're going to make all these different colored plastics. The problem with that is they don't realize there's setup fees for everything. So every time you change color, every time you change material, you're going to pay extra money for that. So that goes into your cost of goods, and that jacks that way up. There's a ton of supply chain challenges, because now if I have 1 million of those blue in stock and I have none of the green, and my customer orders the green, well, it's shit out of luck. It's tons of customer service hurdles, because especially if you have a product under warranty, if we discontinue the green and a year later somebody comes back and only one of their devices, because you have to wear two in case you weren't at the presentation yesterday, well, we can't do anything about it. That's it. And it also limits our adaptability, because you're at the mercy of the plastics. So we tend to use things like decals. You can use different types of hot stamp methods, but something that gets applied to the product rather than is part of the product. In this case, we have unlimited colors, so we can make the sticker literally any color we want. We can even do custom hand-drawn graphics if we wanted to. It's a single manufacturing pipeline, because every product that comes off the line is black. We can ship it to the customer without the stickers, and they can still use it. The stickers make it nice, but you don't have to use them.
So you're pulling a new Ford.
Yeah, pretty much. You can have any touch point you want as long as it's black. Supply chain can focus on one product rather than having to have this really complicated pipeline. And it also limits your SKUs, because if you don't know already, you have to pay for your SKUs. And if you want a custom SKU, it's like $15,000 and then $5,000 a year, and then you have to pay for all your SKUs on top of that. So limiting your SKUs helps you get into Amazon, because you don't want to deal with it when you're ready to expand grow your company. You want to do it early. I would highly advise that you track all your lessons learned. When you're in a corporate environment, this happened at Motorola all the time. The engineers would go, hey, we have an idea. And some guy who'd been there for 30 years would jump out of a cubicle and go, no, don't do that. We did that 20 years ago, and it was a disaster, right? But you don't have that option as a startup, because you're going off of whatever experience your team has. So start to track everything. because this helps you to create kind of a best practice, an engineering guide, for lack of a better term. You can also learn from your competitors' mistakes. Something we did at Motorola is every week all the engineers would get together and we'd tear apart one of our competitors' device, like piece by piece, and look at literally everything. How did they seal it? How did it screw together? What type of materials they were using, how they designed their antennas, and you start to build this understanding for what your competitors are doing, because often they do things that are wrong. Samsung, exploding phones. Yeah. So then, mechanical and electrical, you kind of jump back and forth as you're developing a product. I tend to use Eagle, which was not owned by Autodesk up until like last year. So once again, not an Autodesk pitch, but now they own them. There's a lot of free software out in the market now and these companies will help you to do kind of your design for manufacturing analysis of what you're producing. So won't spend too much time on that. I don't know who said this. I've been saying this for years. I've probably read it in a book. If somebody sees this quote, let me know. I'll stop claiming ownership of it. But we had like the IoT day. We have a lot of software guys in the house. You can't create a good Internet of Things ecosystem with Arduinos and Raspberry Pis. Like there's a limit to what you can do with that hardware. So it's very important for companies that are hardware to understand that they're part of this too, and it's not just a software thing. Manufacturing support is something that I would say 90% of the companies I work with do not even think about until it's far too late. When I was in aerospace, if we designed a actuator for a passenger aircraft, it's one product, but it had 240 to 300 tools that then had to be designed after that product was developed just to make it. Right? So and electronics are a bit easier than that. Deal with FAA and because when planes are in the sky, you want them to stay there unless you tell them not to be up there. But you might have to make your own tooling. A lot of people will go to a contract manufacturer with a product and they'll go, here, make this. And the contract manufacturer might go, no, I can't. But it's not because they lack the capability, it's they maybe never tried to do this before. They might need custom fixturing and tooling. We had our first touch points, we had our first manufacturer putting this together, and they were gluing them together and holding them. And they were counting to like 30. And then they go do the next one, they'd count to 30 again. And you think about how much time they were wasting holding these stupid things when $100 worth of fixturing solved all their problems. So you might have to jump into this side of it, and you might not consider it, because a lot of people think, okay, turnkey, I go hand them my product, they go make it, I don't have to worry about it anymore, and that's really not true. Bug tracking. I used to be of the opinion that customers were not very smart, and I would blame them first. And I have since had to change my method of thinking. So generally I blame myself first, and I do the due diligence and make sure that my product wasn't designed incorrectly, and then we go with, okay, well, the customer doesn't understand how to use it. But you need to be able to track this. So when you're designing a product, keep in mind of how am I going to know serial number, how am I going to know when it was produced, because manufacturing defects happen. I don't have any acceptable defect rate. A lot of people will go, okay, well, in China, if you have a 50% defect rate, they just make twice as many, and then you're good. But that doesn't work when we're talking like you're making the product here. No, they don't. No, they don't. They're not very well known for quality. But monitoring this lets you see things early on, because you might launch a product and it's great for 6 months, then all of a sudden, all of your customers come back and start yelling and screaming because it broke. Advanced failure mode testing, it kind of leads into this. You need to kind of stay ahead of your issues. How am I doing on time? Doing good on time?
Do you have any suggestions on tools for doing bug tracking?
I wish I did. I tend to do it either in Excel or Word, which is probably not the best way to do it. Or if it's something that's a little more systematic, like it's happening from the manufacturer side and they're feeding you that data, you could try to do something like Asana, where you can just kind of use tick marks to say how many units are failing. But I haven't found a very good tool for doing this type of stuff. And most of the manufacturers I work with, none of them use the same tool for it anyway, so there's no universal. So that's something to point at the software guy in the corner and go, that's a good market sector you should probably go after. So who knows about 3D printing? Probably, okay. So everyone likes to use the term digital manufacturing, which is bullshit. Manufacturing's been digital since CNC machines were invented. But just to kind of go through this. So I also am not a spokesman for Ultimaker, but I do own 3 generations of their machines, and they still work every day. So I'm not saying you can get these down to like $300 now. But This is one of the kind of my first lines of defense when I'm designing products, because it's very easy to use. The material is incredibly shelf stable. It's clean. It doesn't really smell very bad. So it allows you to kind of print literally at your desk and test prototypes. I highly recommend that when people design products, you just print a brick. Like if you're designing this watch, just print the overall dimensions. Make sure it looks and feels the way you want it to before you start jumping into other things. The downside, it's lower print quality, and there's some limits on your geometry. Kind of the next step up from there is I'll use a Form 2 style printer. There's a bunch of different SLS printers out there now, but it allows you to print higher quality parts. I brought a few here if anyone is really curious. But it allows you to print, if you're doing like small items, like I'm working primarily with touch points on wearables, so watch-sized devices, we can print all the parts in-house, test all of the designs. If we don't like something, I walk 10 feet to my desk and I make a change and we print another part. So it allows you to iterate very quickly, so that you don't have to go through 7, 8 iterations of the product. You can try to limit that. Selective laser sintering is the way that I highly recommend testing your injection molded products. This will mimic an injection molded product more accurately than anything else. They're dimensionally accurate. You can actually print in metal, which is pricey, but you can. And it doesn't require any support, so that's why it lets you print a perfect representation of your injection molded part. You can put them together, see how they fit, make sure you don't have any interference with your electronics. The machines are crazy expensive, but Shapeways, which is on one of the first slides, they're very cost effective. They'll even get you parts in like 5 days now. It's incredibly quick. I haven't worked with any of the local guys on this stuff. Objet is my all-time favorite machine, but I have only got my hands on this twice. It allows you to do multi-material printing, so if you're doing things like over-molding, injection molding, like that's silicone, we should talk about that. But you do multiple shot injection molding, you can actually simulate it with this machine. In full color. Yeah, the color has limited utility. But yes, you can do it in full color. So now, when we are dealing with any type of hardware, the most frustrating thing about the development process is figuring out what's going wrong. And a lot of companies will go in an infinite loop trying to guess what's wrong, and will waste weeks, months, potentially even a year trying to figure it out. So there are some very simple tools that I recommend. FLIR, you go on Amazon for $200 and you can have a thermal imager with your phone. So what? That I don't know. They have a new one out, so you might want to check. It's still, I think, called the FLIR 1, but there's like a brand new model that they just came out with. So this I use for power supply testing. When we're dealing with any type of battery-operated device, you don't want it to explode. We all agree? Yes? Okay, good. Yeah, so being able to actually test what on my PCB is causing a problem. If I take a board and I use this device, I could tell you which power supply is heating up too much. I could tell you if there's a resistor that's not the right current rating. I could tell you if motors aren't operating properly. And so this is a really tremendously powerful tool to see what's going on. I used to use the touch method where I'd like poke things and see what burned my hand. That's not very accurate.
You could also use single point thermometer.
Yeah, you could do that too. This is a little bit better when you're dealing with things that are transient and they flow. The single point thermometer will give you the reading right there, but I use this, and I'll generally take a photo every 30 seconds and see how the heat's spreading around the board or through the enclosure. So devices that communicate with each other, one of the biggest problems you might have when you're developing libraries and you're working on the firmware is things might not be, you might be sending information, but you don't know if the device is actually receiving it. I cannot count how many hours this device has saved me. So another thing about not just debugging the communications and understanding if the device is communicating the way that you expect it to be, this also really helps you with reverse engineering. So if you have a company's product that you're trying to figure out what they're doing, some of the higher end versions of this, you can actually connect their device to all the pins on a microcontroller and just go run, and it'll tell you you could tell you what it's doing, and it'll usually be able to even tell you what that processor is. And some of them will even do that for like the chips the specialized chips that come over from Asia. It's great for doing failure analysis and for benchmarking your prototypes, because especially if you're making claims about a product, you really should be testing it to make sure that it does that, because there are groups out there that work with attorneys that their entire mission is to find flaws in your product and then sue you over those flaws. When you're testing out boards, this is something that I use almost every day. you can basically I could take the tweezer on different components on a board, and I could tell you what value the resistors and capacitors are in circuit. Really, really great for reverse engineering your competitor's product, the one that I use. And that is it. Do you go on time? Yeah. Any questions? So if you contact me there at that email, I'll send you this presentation. There's a bunch of pages after I listed all the links for the tools, the software that I use.
So we'll do something similar.
Yeah, sure.
Sit down, have a chat.
All right, I will sit.
So we're going to open up to where we have some set questions through Brendan, and then we'll open some questions up through the audience.
Yes. So great, awesome, very informative.
Thank you.
I'm not a hardware guy, so all of that stuff is, you know.
Well, the software guy sat through it, so couldn't have been that bad, right? I figured you guys would have just jumped off and left.
No, it was very interesting. I was, there's a lot more that goes into it that's not as easily accessible as there is in software, right?
Yeah, I mean, the biggest question I'm always asked is, I mean, it even happened on the lunch line pretty much every day. It's like, oh, you're a hardware guy. Oh, I got an idea. How do I make this? And it's like, well, that's a little more complicated than.
Yeah.
Yeah, I don't wave a magic wand.
Software, most of the time, you can just kind of prototype something using open source tools really quick, and then it's done. You know, you have your
Not in hardware.
Yeah, you can. There's a lot of hardware stuff. I guess speaking for Beagle
That's a lot more though.
Yeah, it's not the same as just downloading a couple different libraries and patching them together.
Yeah, exactly.
I think next year you should have a track just for hardware.
Well, that's what I wanted.
That'd be cool.
I was going to have us do a hardware chant, but there's not enough people here to do it.
I'll do it for you.
So, you said something in the beginning about don't wait until it's ready, right? And I think that's a general thing. But how do you know when it's not ready enough to not
Well,
wait?
okay, so advice that was given to me when I first started going out for investment for the different projects I work on is that you never demo your product in front of investors. And that, to me, always seems strange because I always wanted to do that. My whole thing was, well, if they don't understand the product, they're not going to want to invest. So I always did it, regardless of how many of my advisors and teammates would tell me not to. And I kind of take that approach with customers too. Whenever you feel ready to pitch it to your customer, I mean, if you come out with the first prototype and you're willing to go to people and ask them if they're willing to stick it, you know, wherever it is supposed to go, like that means you're ready. You know, with the other products, I mean, if you're comfortable, I mean, it's going to be on your level of comfort with your product.
So
and
it ties back into what you were saying about those unique features for your prototype.
Right.
You have those, and you're confident that those.
I mean, your customers aren't going to be happy if there's like wires spilling out of it and there's duct tape. So, I mean, some products you may need to go the extra step and make it a pretty housing and polish it up. But it's real in terms of like feature set. It's whenever you're willing. That target that I had designed, we started out with 3 modes. We're up to some like 24, 25 now. But you know, we started out with 3, and then we just said, hey, what do you think of these? And they gave us the feedback. So.
You keep getting you sort of
It's your level of comfort. As long as you're confident in what you made and you're proud of it, I'd say go show it.
Okay, very cool. Going off of that, you said now you're with 20-something. How often do you I guess you kind of touched on it with walking over and printing another one. How often do you sort of major prototype things like that in general?
So I have a lot of ideas and not a whole lot of time. And generally what I try to do is if I have a concept that I'm working on or I'm working with the company, we try to get it to the pre-production phase as quickly as we can. Because it might not be finished, it might not have all the features, it might be in a 3D printed housing, but they can get them out there and send them to the potential customers. You know, especially if you're trying to get like advisors. Advisors are huge when you're going out for investment of any kind. The advisor is not going to put his name on your product or his or her name on your product if they can't see it. You know, it doesn't resonate with them.
Yeah.
So basically any idea I have at this point, I try to get to pre-production as quickly as I can, even if you're making like 3, and that's all. Like the prototype target, the second one, like there's only ever been 3 of those, but that the investors never knew because we put it in a nice Pelican case and made it seem like we had more of them. So I think, you know, getting to pre-production as quickly as possible. So I do that pretty much weekly at this point.
And as far as like the iteration process within that is pretty straightforward. Maybe you just go, you have the idea and you go to pre-production with that, and then you wait.
Well, you need
great
to use it. A big problem that you'll have when you're designing things, you lose sense of scale, especially if it's in the computer, because I can zoom in as far as I want and see things, or I can zoom out. So actually, like getting it in your hand, and that's something that happened with the Touchpoint product. Is we had to put it in our hand. So when I 3D printed it, we tested the newer design that we're working on right now. I mean, it has a display. So we wanted how big of a display do you need? What does that look like? So we were able to 3D print a device, put a display in it, and go, it's a little too big, right? I have a certain size wrist, but somebody else might have something that's much smaller. So I think that whole iterative process, especially like industrial design, unless you can like hold it in your hand, you can sit there and iterate in software all you want, but until you actually have it in your hand, you're not going to really know. So I feel like that whole process, even on a cheaper printer, if you can do that every day, like why wouldn't you want to do that? And at least make some, even if it's a minor improvement every day, you'll be so much further along in your competition.
You mentioned designing your own tools, and I think you showed us an example of something you did to hold. Yes.
Yeah. So this was a fixture.
Any other big examples of that? What does that normally look like?
It's going to vary dramatically on how complicated your product is, which could go back to the fact that you did not design it very well. Products should be as easy to assemble as possible. The new Touchpoint goes together with one tool. The target that I use, there's 2 different Torx bits that you need to assemble the entire product.
Okay.
So you want to try to limit the tools. I mean, when we're talking like aerospace, FAA grade, devices, well, obviously every little thing needs a tool. Every time you put a O-ring on or you put wires through a hole, like they need a specific tool for that. I would say try to limit it as much as possible. If you can put your product together just on a table and that's as fast as you'll ever be able to do it, like that's probably the optimal. I mean, actually that's not the optimal. If you could throw everything in a bin and shake it and it puts itself together, like
Okay.
that should be your goal. Like it should almost assemble itself.
Okay, that's interesting because it's pretty much the opposite with software. I feel like is that the tools, when you need to design your own tools, you end up that becomes a product of its own.
Well, yeah.
So,
Yeah. With this, it's
interesting.
kind of the
just
back
kind of-
end. You're trying to speed up production
okay.
because you want to. I tend to make most of my stuff here domestically in the States. I don't usually go overseas to manufacture products. So here in the U.S., it's all about turn. How quickly can we make these things in order to be competitive, so that you don't have to go overseas and go to scale up.
You're finding you're quite happy?
I've been doing it. Well, I was born and raised in a machine shop, and my uncle lost his shop because Northrop Grumman pulled all their manufacturing out of Long Island and sent it overseas. So I have a bit of a grudge. So I try to do as much here as I can. On a component level, some parts are just not made here, period. But at least the manufacturing you can get done here.
So you're able to get tooling people? Because that's the biggest problem right now, is that all the people that can do tooling, it's gone.
Yeah, well, that's one of the biggest problems with manufacturing in general. I was trained by master machinists since I was a kid. So I do my own tooling, but that is kind of a lost art in some ways. There's companies like Protomold that are making a concerted effort to try to give you the avenue, if you don't know how to operate a machine. That's why, places like Tech Shop were great because you can go beat up their equipment and not your own and learn. And I really wish that this was taught, or at least was an option because as a mechanical engineer, I went through 5 years of school for the master's program, and I was in a machine shop once for that entire thing, and it was during my senior design, and they basically just threw everyone in there. It's like, all right, you guys are engineers, you go make this shit, and it's like, that's not how it works. And what you'll notice with a lot of companies that when they're designing products, like who knows about the juicer that just had that whole scandal, Juicero? Yeah, you guys know that? Have you seen the teardown of that device? It's gorgeous. It's like, it's an aerospace grade product, but it's supposed to be a consumer grade product that's cheap. So if you take a look at it, it's like an expertly machined product, but it was designed by engineers who have no idea how much manufacturing actually costs. Right. So I wish that it was there. So it is difficult to find people locally for that type of stuff. But something like Protomold's at least trying. You might have to learn it yourself.
The good news is actually there's a lot of people that are being taught master machinists, like with Mesa Community Center and all of that.
You guys know Mike Rowe,
Yeah.
Dirty Jobs?
Yep.
Yeah. Mike Rowe is a huge proponent for different types like vocational training. You know, welders, machinists, like people actually doing that. So there is definitely a shift that's going more in that direction because honestly, a lot of those guys probably make more money than most of the grads from ASU. And there's a huge vacuum now of manufacturing. Because the sad part is manufacturing experience either literally retires or they pass away, and their knowledge is lost. So it is important to understand that. So thank you for asking that question.
I built a design a component that is using two mediums. One is wooden dowels, and one is PLA. Now I've got a cheap 3D printer. I've got monoprice, just a basic starter kind, and I got 4 dowels I have to insert into the 3D printer. So with the dowels being wood medium, and which is not manufactured any tight specification, and with the error of my printer, 3 out of the 4 will give me all I'm looking for is a snug fit.
We'll talk about that after, because really that's specific. But yeah, I can talk to you about it.
Thank you.
Now let's hold our questions until they go through this, please.
Okay, sorry.
I don't know how many.
I've got just a couple more. Can you talk to us a little bit more? Some of us, I know I guess your CEO had a presentation. I unfortunately wasn't able to make it. Can you talk to us a little bit more about what the touchpoint device is and how?
Sure. So the touchpoint device, it's a medical wearable device, and it's based off of EMDR therapy, which stands for eye motion desensitization and reprocessing, which has been a treatment that around since 1989. They use it a lot for treating PTSD, and generally in the past they would use a light bar, and you'd sit there and you'd follow it back and forth with your eyes, or it would sweep back and forth, and it was that kind of alternating motion of moving your eyes back and forth that takes you out of a fight or flight response, and that primarily operates in the back of your brain, and moves you to a more logical mindset where you could actually process the traumatic events that you had experienced. And then Dr. Amy Sarin, who's one of the co-founders of that company, runs a PTSD clinic and an EMDR therapy clinic in Prescott. Is it Prescott? Okay. And so they kind of wanted to miniaturize and commercialize that product, and they use what's called BLAST, which stands for bilateral alternating stimulation, with a tactile device. So they're basically small haptic devices that I have in my bag if anyone's interested in seeing them afterwards. And you wear them either in your wrist, you can put them in your tank top straps, your pockets, your socks. Right now we're in clinical trials with those at a couple different universities for testing the efficiency for ADHD, and they're used a lot by the autism community to help people who have they're oversensitive to like tactile feedback, to help them kind of calm their nervous system down.
Okay, cool. So you said initially those first designs, people said they were Tide Pods.
So yeah, I think the Tide Pod comment came somewhat.
Yeah.
So
No, I agree.
the
Especially-
marketing team did a phenomenal job of taking photos of these, but it's a device that you're supposed to be wearing all day, so it needs to look nice, like it needs to be appealing. Nobody wears jewelry that's ugly, right? Does anybody? No. So the company, there's form and function, and there's like a happy marriage of the two. But some companies go hard to the function side, and they don't really care much about the form, and they just kind of, the case is the case. This is an example of not modeling your electronics properly. So instead of knowing how much space I have above the board for the housing or how things will fit, they kind of just guessed. And they were like, this looks like it'll be enough space, but it's not an efficient design. So the housing just looks terrible. It's glued together, which posed a lot of problems because you can't fix them. So if they break and the customer sends them back on warranty, the device pretty much is done. So kind of thinking, do you even want to offer warranty for your product? It's your company, you do what you want. But if you're going to offer a 1-year warranty and your product's not going to last a year, you need to make sure that you either have some way of refurbishing it or it's so dirt cheap that you just don't care, which is probably not that option for most of us.
Throw some crystals and gold plate it, you'll be fine.
Yeah.
Yeah, so at this point it was not working and it didn't look good.
And the manufacturing time was too high.
Okay.
Because we are doing it here domestically, so seconds matter.
Right.
We're talking about the gluing fixture. 30 seconds per device when it only takes 10 or 15 seconds to put it together. Well, that's 60% of your assembly time is just the guy sitting there holding it, together,
Right.
right? So we can make we can up our production almost threefold, 3 times by just adding a fixture. But the contract manufacturer won't tell you that. You need to work with them.
Right.
Sometimes a lot of people will trust them, and they get the dollar figure for how much it costs to actually assemble a product. And they're like, all right, this is what it is. But what they don't realize is you need to help them speed that up, because that comes back into your pocket.
See, in China with the tooling, you'll be making 10 of those a second. That's
Yeah, but 8 of them will fail.
It depends, if you do the right one.
Yeah, so just a little bit, could you touch on maybe some of the decisions made to solve those problems?
Yeah, sure. So the first decision that was made was to throw the design out and start from scratch. A lot of companies will waste a lot of time and money going around in circles trying to fix and patch up all these problems for a faulty design, when they'll spend $2 million on that when they could spend 250 grand and just done it from scratch. So generally, if I come in as a consultant, I usually advise they scrap it. If they can't do that for cash reasons, then we have to work around those. For the first decision right off the bat was to make it look nice, and to give some way of customizing it without having to change the plastics. Because the biggest problem here is you're making them in batches, and if I sell out of my blue and now I'm making pink, well, the customer that wants blue is not going to go, okay, I'll take a pink one, generally. The second thing was to make them, because we offer what I consider to be almost an industry-leading warranty program on these, where we kind of take them back, almost no questions asked, and replace them. So being able to take units that come back from the field and have some way of reworking them to try to save capital. So we basically made it screw together. I don't know if that's true. Yeah. So we basically made the back screw together, really worked on sealing it, went through the laundry list of complaints. You really have to interface with your customer, because they'll tell you exactly what they want. Like, they don't hide it. They will not hide anything from you at all. We're kind of in an open office environment, so I sit right next to the customer support team, so I hear every call, whether I want to or not. So one of the main motivators for me is to come out with a product where they're not going to get the calls, right? So we're trying to fix the problems that customers have. So making the device splash resistant. A lot of kids use these products, so the kids aren't they don't care.
Right.
They'll smash into a wall or.
Right.
But is that your last question?
That was pretty much it for me. So we can open up.
The woman behind you raised her hand first.
So when you work with such a business, how do you plan, knowing technology is changing so quickly, that so you're investing a lot of time and money and resources into this, then next year there's going to be something new and you need to modify it. I know you're constantly addressing that, but when you're looking at putting your resources into something like this for this year's model, how do you constantly be paranoid about that?
Well, I'd say you can't be too paranoid about that, because you just won't sleep. Technology is going to change all the time, but it's usually like the major things, like the wireless technology that is primarily available. Things like pre-FCC certified modules. Displays are the bane of my existence, but if you're going into it with those major components, batteries, things like that. You need to try to plan out a few years in advance, and that's where having a network of talking with CMs and having Arrow or Avnet are the big guys in town who supply components. If you're talking with them, they'll get you in touch with the manufacturers, and you'll know with the big guys what their plan is 5 years out. A lot of them will have automotive grade components, and those at a minimum they have to have a certain number of years where they're going to supply those. What you don't want to do, and what actually happened with this product, so it's a good thing you brought that up, if you have a single source for a part, and it's kind of a no-name company or somebody who's kind of on the fence, that is a very big risk, because they can go out of business next month, and now you need to re-engineer. So for us, bringing engineering in-house kind of helps to alleviate that, because we don't need to go out. I mean, we actually had one company where we were using their Bluetooth modules, and we didn't like their pricing and the features, and they said, okay, well, you can take it or leave it. So we just left, and we just use somebody else's. Whereas if you were going externally to do that with a consulting group, it would take time. So it really depends on if you have the engineers in-house. A good engineer, if you have a Bluetooth problem, you could probably re-engineer that board within a week or two. if it's just a minor change to a new part. But I'd say, using parts from well-known vendors versus the super cheap stuff you can get overseas would help with that. But I mean, honestly, a lot of times it's a gamble. You just have to believe in the part. I usually don't use parts unless I've used them in other devices. If that answered your question.
Made you have a question. Stephanie? It's a silly one, but embarrassing. It's always figured questions. The sticker is great because customization is so important for the consumer, products, and it is expensive to customize and track all that when you're a startup, right?
Mm-hmm.
But what have you found? Were you worried? Would you just make them easily peeled off and easily replaced? You didn't have to worry that they wore off, or how did you handle that?
So I have a very good line of communication with 3M. And there are certain companies, I mean, there's adhesive companies all over the world, but then there are adhesive companies that give a shit about their product. And a company like 3M, they actually have done all types of case studies on pretty much any adhesive they make, in terms of, if I'm making a patch that goes on the body, how long is that patch going to stay on? Is there any residual effects on the skin? So they give you all the specifications on their materials, and usually what I'll do is I'll try to work with them, because they obviously want to sell me their tape. So I'll go to them and say, hey, I want a sticker on this, and these are my requirements. I want to be able to peel it off without residue. I don't want it to wear off on its own, and I want to be able to print whatever on it. And then they'll come back and usually help you to develop that. Same thing with materials, like polymers. I mean, for you, the silicones and plastics, you can go to the vendors that formulate them and ask them for their input, because you're not the first one to use a silicone overmold in a product, so they'll be able to help you with that.
3M will do it for free.
Yeah, 3M actually will go even one step further than that. And if I have a printed circuit board, a flexible board, they'll give me the whole stack up and call outs for all the materials and everything, because they're making their money on the materials.
So that'll be our last question. Thank you very much. That was a
Thank you for having me.